Welcome back. In today's lesson, we will explore how characters and strings are represented in memory. In our previous session, we learned how the system handles integer storage. By comparing these two methods, you will gain a clearer perspective on how data is managed at a low level. This foundational knowledge is essential for our upcoming lessons on typecasting, where we will learn how to convert data between different types efficiently. Strings are composed of various characters, including letters like A and B, as well as special symbols like question marks and currency signs. While these characters are easily accessible on our keyboards, global digital communication requires a universal standard to ensure that data is understood consistently across all systems. One such widely adopted standard is UTF-8 encoding. Python utilizes this standard by default to store characters. Let's examine the UTF-8 encoding table. In this standard, the uppercase letter A is assigned the decimal value 65. When you type a capital A on your keyboard, the system stores that value, 65, in a single byte of memory. It is important to remember the specific 1-byte allocation for the character A. Let's look at a demonstration to see how this is handled at a low level. Similarly, let's locate the digit 9 in the encoding table. Notice that when you press 9 on your keyboard, it is mapped to the decimal value 57 in memory. Now consider a string variable, such as x equals A9. In this case, the computer stores a sequence of characters. Let's observe the following demonstration to see how these individual character values are organized and stored together in memory. Now understand the differences. Take an example, x equals 9 and y equals A9. In the first case, 9 is integer, so binary value 9 is stored in memory. In the second case, 9 is character format, means binary value 57 is stored in memory. In memory level, both types are different. This is the point you should catch. Let's look further into the UTF-8 encoding table. For example, the character Latin capital letter S with acute is assigned the decimal value 346. To store this value, the system requires 2 bytes of memory rather than 1. This universal logic applies to all global scripts, including Chinese, Hindi, and Japanese characters. Each is assigned a specific fixed decimal value under the UTF-8 standard. I encourage you to search for the full UTF-8 table online to appreciate the vast scale of this encoding system. You should now have a clear understanding of how Python represents and stores characters in memory. Happy learning! If you're enjoying our journey together, don't forget to like, share, and subscribe to stay updated. For more deep dive resources, including practice quizzes and real-world projects, visit the Wisdomers app at www.wisdomers.in. Let's keep building together.